we're gonna start the first experiment to make some chloroform. So we've got the acetone and the bleach, which is gonna be used in the haloform reaction to make chloroform, a trihalogenated carbon molecule. And so to start off with, we have this bleach, which I cooled in my freezer for around 3 hours. And we're adding 90 milliliters of acetone in half fragments. So I've got about 45 milliliters here, and we're gonna add it slowly. Now we're gonna cap, and we're gonna shake the bleach to mix it up, so we know that there's an even distribution of acetone to react with the bleach. And the bleach here is our limiting reagent because it forms an azeotrope with chloroform, and we don't want that. So now I'm just gonna pop the cap on like this, and I'm gonna pour out for ourselves another 45 ml of acetone. And in about 30 minutes after this is all done after the acetone is all done reacting in the bleach solution, I will add the rest and shake again, and then we're gonna let this sit overnight, because what's gonna happen is the chloroform is gonna form in little globules. It's gonna be all throughout the solution, so we're gonna wait and let it fall to the bottom. Okay, so I emptied out all the water and the bleach, and the chloroform came out obviously in the last fraction, and so I put all the water into a little waste container to save for later. And as you can see, there's the chloroform, and there's just some excess water that I need to dump out. So now I'm going to decant as much water as possible into here, and then put the chloroform into the separatory funnel. And we'll remove the chloroform fraction, and then we're going to dry it with some sodium chloride to remove any excess water. So I'll get back once I've decanted off all this. Okay, so now we've got the chloroform in the sep funnel. So that's little layer up there, as you can see, is water. So I got out a lot of water. So this whole portion right here is our chloroform, right? This whole big section right here. So we're gonna empty it out into this beaker, and then we're gonna put the chloroform back into the sep funnel and wash it with some sodium chloride solution. So I'm gonna empty it out real quick and then put it back in, and I'll show you the sodium chloride. Okay, so now we're gonna do the sodium chloride solution. So here I am adding that. I'm gonna add about 50 mLs. So 10 more. Sorry about that, there's some construction going on next door. So now that I've added that, I'm going to shake and vent it, and I'll be right back. And as you see, I'm letting the water separate back out, and then I'm going to collect the bottom layer again, and then we will go and distill it. Okay, so here we have it, our crude product. We're gonna distill it, and we'll see how much we get. So now, for anyone that's curious about how you get rid of the waste, because you're not supposed to pour chloroform contaminated water down the drain, because chloroforms are pretty nasty carcinogen. Chloroform degrades in alkaline conditions to sodium formate, which is benign. So you just pour the water from the bleach bottle into another container, or back into the bleach bottle. I just had another container laying around, so it was easier to put it back into it. And you let it sit for a couple of weeks, and it'll degrade, and then you can put it down the drain. So it's easy as that. Or you can put it in a sodium hydroxide solution, or something like that. If you have just regular chloroform that you don't want anymore, a sodium hydroxide solution would probably be better. So that's for anyone who's curious about how to get rid of chloroform waste. Well, there you go. Okay, so now we're going to be doing a simple distillation of the chloroform to purify it. So We will be collecting everything that comes over above 60 degrees Celsius. Everything below that we will discard. So I have a small flask to collect everything that comes over below 60, and everything that comes over 60 I'm going to collect on this because I measured it. I weighed it, so I can determine our percent yield for this reaction. Okay. Here we have our final yield of chloroform, about 75 ml, to give a 55% yield. And as you can see with chloroform, it has a pretty cool optical density, so it refracts light very differently than water. And so everything that you see through it looks pretty cool. But I'm now going to store it in an amber glass bottle that's wrapped in aluminum foil to make sure that it doesn't degrade into any phosgene. And you can also add 1% methanol by volume or absolute ethanol, but I'm using mine soon, so I don't plan on doing that. Well, anyways, I'm gonna store this and then we'll move on to the phenol synthesis. All right, have a good one.